Hey guys, welcome back to the recitation on fundamentals of NumPy. In this video, we'll learn about different ways we can combine data in using NumPy arrays. So let's first talk about concatenation. A concatenation operation joins a sequence of arrays along an existing axis, and all the arrays must either have the same shape, except in the concatenation dimension, or be empty. So let's look at a few examples. The first array has a shape of 2, 2, and the second array has a shape of 1, 2. And so we can concatenate them along the axis 0 because the shape of these two arrays is different along axis 0 and same along axis 1. But we cannot concatenate these arrays along axis 1 because they have a different shape along the axis 0. And so we see that when we concatenate them along the axis 0, the resulting concatenated array has a shape of 3, 2, and which we get by adding 2 and 1 along the concatenating dimension. But when we try to concatenate these two arrays along the axis 1, we get a shape error that along dimension 0, the array at index 0 has a size of 2 and the array at index 1 has a size of 1. Let's look at another example. Here we have two arrays with the same dimensions, 3, 4, 5, and so we can basically concatenate them along any dimension. And so if we concatenate them along axis 0, we get a new array with the shape of 6, 4, 5. If we concatenate them along axis 1, we get a new array of the shape 3, 8, 5, and if we concatenate them along axis 2, we get a new array with the shape of 3, 4, 10. Now let's talk about stacking. Stacking is an operation that joins a sequence of arrays and creates a new axis. So all the dimensions have to be same because here we are creating a new axis. So let's suppose we have two arrays with a single dimension, and let's try stacking them along axis 0 and axis 1. Here we can see that both the arrays have only one dimension, but after stacking those arrays, we have one more dimension, and the new array has a shape of 2, 3. And if we stack them along axis 1, the new array has a shape of 3, 2. So the axis parameter here defines the index of the new axis that is being added to the result. Also, if we stack these two arrays along the axis -1, that basically means that we're adding the new dimension along the last axis. Let's look at a couple more examples. Here we have two NumPy arrays with the shape of 3, 4, 5. And if we add a dimension along axis 0, we get a new array with the shape of 2, 3, 5. And similarly, if we add a dimension at axis 1, we get a new array with a dimension of 3, 2, 4, 5, and so on. Now let's talk about the repeat operation. The repeat operation repeats elements of an array. The number of repetitions of each element is broadcasted to fit the shape of a given axis. The axis parameter specifies the axis along which to repeat values. And if we do not specify the axis, the repeat function first flattens the array and then repeats the elements. So for example, if we have an array which has 4 elements, which are 1, 2, and then 3, 4, and if we use the repeat function and give it the number of repetitions, it first flattens the array and then repeats the elements. So we can see that the new array has elements 1, 1, 2, 2, 3, 3, 4, 4. And the shape of the new array is 8, nothing. If we use the repeat function with the number of repetitions and the axis, it repeats that axis that many times. For example, we can see that the inner arrays are being repeated 3 times. So we have 1 and 2 repeated 3 times, and 3 and 4 repeated 3 times. And the new array has a shape of 6, 2. Similarly, if we use the axis equal to 1, this is the output we get, and this is the dimension of the output. In this example, we can see that the number of repetitions can also be an array. And so here we can see that the first inner array has been repeated twice, and the second inner array has been repeated 3 times, and the shape of the resultant array is 5, 2.